So the first thing that I want to show you is that basically every power line emits an electric field independent of whether some household appliance is plugged or not. So when we're getting closer, here you see that the voltage per meter increases, and the measurement device shows a red reading. With this measurement device, you could also follow up and see where the electric power line is running inside the wall, which is actually over here. So you can clearly read the measurements of around 370 volts per meter in this case of the electric field that we're measuring at the moment. So now I'm going to plug a lamp, and it's also interesting to see that also the power line itself already emits an electric field of around almost 400 volts per meter in its vicinity. Fortunately, if we move away with the measurement device, we will notice that the strength of this field sort of dies away quite fast. Now at a distance of about 25 to 30 centimeters, we are down to only 8 volts per meter. At first, I'm going to show you a measurement near a light bulb, a traditional light bulb, that shows even though the light bulb is switched off, we have an instrument reading of 480 volts per meter. Also, the supportive metal structure, the metal grid underneath the lamp shield, apparently still has a relevant radiation of 540 volts per meter. So how is this possible? I'm going to switch on the lamp now. Yeah. So now we see that even when the light bulb is switched on, we have this reading of about 420 volts per meter. And the metal support structure displays a radiation of 380 volts per meter. In a seating position next to the lamp, we would have approximately 40 volts per meter. The interesting thing that I'm going to show you is that the strength of the electric field depends on the way in which the power plug is plugged into the distributor. And so now we're going back to measure the lamp shield, which here reads like around 200 volts per meter. And up here, again 300 volts per meter. And if we switch off, we see that the voltage goes down to about 80 volts per meter. So we see that with the plug plugged the other way around, we have a reading of only 30 volts per meter in the close vicinity of the light bulb. And we quickly show that the plug is in, actually. And this all depends, and nevertheless, the interesting thing is that the grid, supportive metal grid structure actually shows more, which is 114 volts this time. And if we go closer to the wall, in between, the voltage per meter fades away to a lower value. But if we get closer to the wall, the surprise is that again, the voltage rises to above 200 volts per meter, which is considered an extreme value according to the measurement device ER2. So how is this possible? Throughout the course of the video, later on in the video, I will give you an explanation for this effect. Now, this difference of the reversal of the power plug And the difference in the volt per meter reading that we get is, of course, quite surprising. And so therefore I would like to examine briefly the differences in the plugs that we find in Europe and in the United States, for example. In Britain, for example, we have a plug system that is comprised of the conductor, the neutral conductor, and the protective conductor, which are arranged in this way, which allows only for one precise way in which a power plug can be inserted. So in this way, it is always guaranteed that the neutral conductor is connected, the neutral conductor of a device is connected to the neutral conductor of the power plug in the wall. While in most European countries, we have a system where the three conductors are aligned in such a way that a reversal of the power plug is possible, and therefore the relation of neutral conductor and the normal conductor can be exchanged. Also in the United States of America, they have a much more precise plugging system than in most countries of Europe, which is this one, which is a kind of smaller version of the one that can be found in the UK, which also has a very defined position in terms of conductor, neutral conductor, and protective conductor. What we are seeing here is the very surprising measurement of 430 volts per meter, which seems to emanate from the wooden structure of a cupboard. So how is that possible? The simple explanation is that there is a light appliance built into this cupboard, which is, even though it's not switched on yet, apparently it is already effective. I'm going to switch it on via the foot switch here, and funny enough, we see that the value has dropped down to 270 volts per meter. Might this have something to do with the way that the power plug is inserted? And we're also quickly going to show now the light effect that is actually on top of the cupboard. Now I have changed over the position of the power plug in the socket, and we see that this extreme value that we had before of about 400 volts per meter is gone. At the same position, we have only 25 volts per meter. So the possible explanation for that is simply that the light appliance must radiate its electric field into the wooden structure of the cupboard, and the wooden structure of the cupboard itself then radiates the field over its entire length. Now here we have only these low values of up to 70 volts per meter, and if I switch the power plug, then all of a sudden we see that the reading of the meter is up to 400, almost up to 400 volts again. I repeat the procedure. And we see that the value has come down to, in this case, 89 volts per meter. If I measure directly at the wooden surface of the cupboard at the side, we see that we get a reading of slightly above 300 volts per meter, which is still considered extreme by the measurement device. And if we move over to about half a meter away to a seating position next to the table, we still get a reading of approximately 35 volts per meter. In this part of the video, I want to show you an effect of the electric lamp emanating a field. We are here at about head height, measuring the electric field that arrives here at the sofa seating position. From the lamp, it's about 64 volts per meter of electric field strength. And of course, this is not really a recommendable value because in the long run, this would certainly be detrimental to your health. In order to show you that this is really a relevant field strength here next to the lamp, I'm going to do a measurement of body voltage now. Okay, cut. For this purpose, for measuring the body voltage, I'm going to use this multimeter that can measure impedances and current, but also voltage, DC or AC voltage. So we're going to switch that to AC voltage now, to alternating current. And I'm going to show you that you have to put, of course, this is a measurement of voltage difference between the two terminals of the multimeter. One of the terminals needs to be connected to ground as a reference plane, and the other one is a probe that touches my skin, and you will see what happens when I touch my skin. Poof, 3.5 volts is my actual body voltage. I put the probe away again. There is a let's say residual voltage of about 0.5 volts that remains, which is simply from electrical fields coupling into the wires of the measurement device. But here again, if I touch my skin, 3.3, 3.5 volts again. So that means that as I'm sitting here on the sofa, all the electrical fields around me that couple into my body make my body essentially have this voltage of 3.5 volts on its surface. And I'm also going to show you that it makes a difference if my body is closer or further away from the lamp. So what I'm going to do now is I'm going to move my hand closer to the screen here of the lamp, and the display of the multimeter goes up to 3.7. Before it was at 3.8 volts per meter. I move the hand away again, and we are down to 3.2 volts per meter. So this is a clear sign. I'm going to do this once more. So we are at 3.3 volts per meter, and now I'm going to move closer with my hand. I'm not even touching the lamp, just moving my hand closer to the shield makes my body absorb more electric field, and so the voltage has gone up to currently 3.6, almost 3.7 volts per meter. So I think with this little demonstration, I hope I was able to make it clear that it is quite important to stay away from household appliances, electrical appliances that emanate electric fields in order to keep a safe distance and have your body exposed only at a minimum necessary level to electric and magnetic fields. The last measurement I'm going to show you in this video is to prove that actually every metal structure is effective as an antenna. And one example I can show here, this is an old stove, which obviously is made of quite a lot of metal. And if I move close to the handrail here, you can see that we again get values above 100 volts per meter. I move slightly away and we see that the field strength dies off quite fast. This is true for the handrail, as well as if I move closer here to the chimney part. We also see relevant radiation that touches onto the severe value of 80 volts per meter in that case. And I move away again, so the field strength dies off. And I move closer to the wall again, which we have seen before, and we see that also at this part of the wall we have 102 volts per meter. So the explanation now why we get this electric field emanating from what is a brick wall essentially behind is simply due to the fact that here also the dielectrical constant comes into play, and it is fair to assume that the reason why we get this electric field emanating from the wall is simply due to all the electrical power lines that are built into this wall couple into the bricks of the wall, and therefore the bricks emanate this radiation in form of the electric field. As a closing clip, I want to quickly show you this book by Dr. Joseph Mercola, which I found very interesting as it deals with electromagnetic fields caused by cellular phones, digital TV, Wi-Fi at home, laptops, etc. There are many household devices, the intelligent ones that also radiate and are steered by communication that is propagated by electromagnetic fields. And this is a very well-founded publication, because Dr. Mercola has a lot of references included in this book. Of course, also very interesting graphics and a lot of medical explanations. So this is extremely well founded, because almost with all chapters you find between 50 and 100 literature references. And these literature references are usually peer-reviewed papers. So this is solid scientific work that his book is based on. Thank you very much for your attention. If you have liked my presentation, then please leave a like. Maybe you even want to subscribe to my channel or leave a comment in the section below the video. Also, make sure to read the text below the video. Thank you very much. Until next time.